NB-IoT crash course. Tonex offers LTE-M and NB-IoT crash course to all the engineers, technical and product marketing professional working for wireless operators. Price, $2,999. Length, 2 days. Continuing education credits, 13 PhD. LTE-M and NB-IoT crash course is a 2-day customized LTE training focuses on fundamentals of LTE access technology focusing on LTE-M and NB-IoT. The training course provides an in-depth overview of the various aspects of the new LTE-based radio, LTE-M connectivity and NB-IoT concepts optimized for IoT. Internet of Things, IoT, has demonstrated a clear market need for many utility, power and energy business use cases. Sensors must have battery-efficient connectivity to unlock the true potential of IoT. LTE-M is the simplified industry term for the LTE-eMTC Low Power Wide Area (LPWA) technology standard published by 3GPP in the Release 13 specification. It specifically refers to LTE-CAT-M1, suitable for the IoT. LTE-M is a low-power wide-area technology which supports IoT through lower device complexity and provides extended coverage, while allowing the reuse of the LTE installed base. This allows battery lifetime as long as 10 years or more for a wide range of use cases, with the modem costs reduced to 20 to 25% of the current eBurst modems. LTE-CAT-M technology is one of the two answers that 3GPP has for the rise in IoT-only network technology. NB-IoT and LTE-M enable IoT applications today. LTE-M, also known as eMTC and CAT-M1, and NB-IoT are both good connectivity options for industries looking to take advantage of low-power wide-area network (LPWAN) technology. But which is the best choice for your low-power IoT application? Deciding between LTE-M and NB-IoT requires an understanding of the key differences between these two technologies, such as latency and speed. Carefully consider what your needs are before you decide on a solution. After analyzing the similarities and differences between LTE-M and NB-IoT, you can make an informed decision that will set your system up for success well into the future. Intended audience: engineers, technical and product marketing professional working for wireless operators, utility companies, equipment and device manufacturers, as well as security professionals, IoT architects and designers. Learning objectives: list IoT and 3GPP, GSMA, eMTC and ETC references. Differentiate between 3GPP and non-3GPP IoT standards. Describe 3GPP network characteristics. Describe cellular network architecture and LTE radio and backbone. List LTE radio and backbone features. Learn more about 3GPP standardized IoT features. Distinguish among eMTC, eMTC, LTE-M, and NB-IoT. Describe IoT and LTE-M use cases. Differentiate between LTE-M and NB-IoT standards. Explain wireless optimizations techniques, tools for IoT such as Power Save Mode, PSM, and EdgeWorks. Course agenda. Overview of basic 3GPP and LTE network terms. 3GPP network characteristics. LTE radio and backbone features. Overview of 3GPP, GSMA, eMTC and ETC references IoT. 3GPP standardized IoT features. Overview of LPWA, comparison between LTE, NB-IoT, and LTE-M. Overview of LTE-M features. LTE-M architecture. LTE-M cellular technology details. 5G systems and IoT. LTE-M design, implementation, operations and maintenance, O&M, roadmaps. Tonex offers the other 3GPP technology is NB-IoT, narrowband IoT, which uses an even simpler access scheme, single carrier frequency division multiple access, to further drive down cost and complexity. As a dedicated LPWAN standard, IoT LTE-M enables lower costs, small footprints and innovative low-power optimization. It fills a growing need for IoT solutions and is driving the marketplace forward as billions and billions of new devices get connected. There is not one ideal IoT modem that is one size fits all. The type of application will determine the appropriate type of modem, and it is likely that as the technology develops, the capabilities of modems and range of modem options will expand as well. Learn more about LTE-M and NB-IoT crash course. Visit tonex.com for more information.